Hello everyone, class 12th topic is alcohol and its type. In previous videos we have covered the chapter haloalkane and haloarine. Two organic compounds we have covered. Now it's turn of third organic compound, alcohol. The general formula is ROH, where R is representing alkyl part or alkyl part. Alkyl part means normal hydrocarbon chains like CH3, CH3, CH2 chains. Alkyl means benzene ring, and then C means hydrocarbon chain, and then it will be connected with OH, like this one, CH2, CH3, 2, OH, like this. So aryl part is there, benzene ring is there, alkyl part is there, so that's why we are calling it alkyl part. And here we have only alkyl part, means normal hydrocarbon chains, methyl, ethyl, such chains. R is connected with oxygen. Oxygen is making two bonds. When oxygen is making two bonds, it have two lone pairs and hydrogen is there. So this is the general formula of alcohol, ROH, like CH3, OH. So this organic compound will come in the category of alcohol. One carbon containing alcohol. Similarly, you can increase the number of carbon atoms and the valencies will be satisfied by hydrogens. So this is another alcohol molecule, ethanol. In this fashion, we can write many alcohol particles depending on the size of alkyl chain or alkyl chain. Now types. 1 degree, 2 degree, 3 degree alcohols. A carbon which is sp3 hybridized connected with OH. Watch carefully. This carbon should have a hybridization of sp3. It is connected with OH, is further connected with single carbon. Such alcohol will come in the category of 1 degree alcohol, which are also known as primary. Secondary alcohol condition, the carbon which is sp3 hybridized connected with OH should be connected directly with two carbons. It will be 2 degree alcohol, which we also call secondary. 3 degree, easily you can draw OH. This carbon must be sp3 hybridized. If it is connected directly with three carbons, so such type of alcohol will come under the category of 3 degree, which is known as tertiary. One more alcohol is there, normal one, which we call methyl alcohol. Methyl alcohol, in which only one carbon is there, like this. Satisfies its valencies. This is methyl alcohol. So 1 degree, 2 degree, and 3 degree alcohols and methyl alcohols. If I ask what is the degree of this alcohol, first you need to understand this R. It is not a benzene ring because pi electrons are not available. It's a alkyl chain C6H5, C6H11. Two hydrogens will be here, two hydrogens here, this one, and one hydrogen will be here. Now this carbon to which OH is connected have a hybridization of sp3. How I have checked hybridization? If carbon is making all four bonds single bond, single bond, single bond, hybridization will be sp3. Now OH is connected to this carbon And this carbon is further connected with how many carbons? Directly 1 and 2. So the degree of this alcohol will be 2 degree. Similarly, if I have written this, so check what is the degree of this alcohol. OH is connected to this carbon, which is sp3 hybridized, because it is making single or 4 bonds. 1, 2, 3, 4. Now it is connected with how many carbons directly? 1, 2 and 3. With 3 carbons directly it is getting connected. So the degree of this alcohol is 3 degree alcohol. In this fashion you can find out 1 degree, 2 degree and 3 degree alcohols very easily. Now next types, allylic alcohols. What are allylic alcohols? OH connected to the carbon should be sp3, which is further directly connected with doubly bonded carbons, alkene carbons. The hybridization of this carbon is sp3, this carbon to which OH is connected, which is further directly connected with doubly bonded carbons. This condition is of allylic alcohol. Now allylic alcohol is also of 3 type: 1 degree, 2 degree, 3 degree. How? Check this allylic alcohol. The OH is connected with the carbon which is further connected with 1 carbon. It is 1 degree allylic. If we have this condition, OH is connected to this carbon whose hybridization is sp3. Look, I am not drawing hydrogen, so please draw hydrogens by yourself. When you will draw hydrogen here, so automatically you will come to know the hybridization of this carbon is sp3. Similarly here, 2 hydrogens will come there, so hybridization is sp3. So this carbon have hybridization sp3. Now it is connected with doubly bonded carbon this side, so obviously it's a allylic, okay, with 1 carbon here and with 1 carbon here directly. So it's a 2 degree allylic. 2 degree allylic. Similarly, we can have this one, sp3 hybridized carbon, 1, 2, 3. It's a 3 degree allylic carbon, allylic alcohol, 3 degree allylic alcohol. So these are allylic alcohols. Now benzylic alcohols. Benzylic alcohols. Condition, please check. Benzene ring, carbon, OH. This carbon should be sp3. OH is connected to the carbon which is directly connected to a benzene ring. Such condition is benzylic alcoholic condition. Now benzylic alcohol is also of 3 type: 1 degree, 2 degree, 3 degree, primary, secondary, tertiary. OH connected to sp3 carbon which is further connected to single carbon. Here we have a carbon. So this is 1 degree benzylic alcohol. If we have this condition, hybridization again sp3, OH is connected to sp3 hybridized carbon which is further directly connected with 2 carbons, one this side and 1 carbon of benzene ring. So first of all it is benzylic alcohol and the degree is 2 degree. Similarly you can make 3 degree if we have 1 more carbon here. So degree will change to 3 degree benzylic alcohol. Next and last, vinylic alcohols. If OH group is connected with doubly bonded carbon whose hybridization obviously will be sp2. This is vinylic alcohol. Now, what is the degree of this vinylic alcohol? This carbon whose hybridization sp2 is connected with one carbon, so it's a 1 degree vinylic alcohol. 1 degree vinylic alcohol. Similarly, we can have such condition. OH is connected to sp2 carbon, doubly bonded with this carbon and directly with this carbon. So what is the degree of this? 2 degree vinylic alcohol. So these are the categories we have: 1 degree, 2 degree, 3 degree alcohols, then allylic, benzylic and vinylic, and their further types. If we have more than one OH group, like this is suppose alkyl part, 2 OH groups are there. If 2 OH groups are there, we call such alcohols dihydric alcohols. Di means 2. Hydric means OH group. These 2 hydroxyl groups are there, so we call them dihydric alcohols. If only one is there, so we call it monohydric alcohol. Similarly, if 3 are there, again I am repeating, hydrogens I am not writing, draw by yourself. So if 3 are there, so we call it trihydric alcohol. And similarly, we have polyhydric alcohols in which more than 3 OH groups are available there. That's it. This is the end of the type of the alcohols. Now in next video, we will find out preparation methods of alcohol. Thank you very much for watching the video.